Now in this video I'm just going to basically do a quick revision of substitution and integration by parts. So now if we look at this problem, suppose you want to use substitution on this problem. So we're going to substitute the denominator u equals x squared plus 2x plus 1. So if we make that substitution here, we're going to change the boundary. So now you substitute 0 here. If you substitute 0 here, you're going to have 0 squared plus 2 by 0 plus 1. And 0 squared, that's 0. 2 by 0, that's 0. And you're going to have positive 1. So the lower limit is now going to be 1. Now, you're going to substitute 1 here. So you're going to have 1 squared, which is 1, and 2 by 1, which is just 2, and then you have 1 here. So you're going to have 1 plus 1, which is 2, plus 2, which is just going to be 4. So now we change the limits of integration. So whenever you make a substitution, you can change the limits of integration, or the boundaries of this integration. It's just a revision. So now, if u equals x squared plus 2x plus 1, that means that du, you're going to derive both sides. Du will be 2x plus 2. Du will be 2x plus 2 dx. Then you just shown that this was derived with respect to x, and now notice that you can find dx on top of that. So that means that dx will be equals to du over 2x plus 2. But notice that here you can factor by 2, so you'll have du over 2 into x plus 1. You're going to have something like this. You're going to have du being dx being du over 2 into x plus 1, because here we just factored by 2, because here you can basically see you'll have 2x, and 2 by 1 will give you this 2. So now you're going to have x plus 1 divided by u, because this basically it's u. Substitute u in terms of that. And now dx is du over 2 into x plus 1. So notice that the x plus 1 and the x plus 1 will cancel, and then you're going to have the integral from 1 to 4. And now you can take the 2 outside, and it's below the fraction line, so it's going to be half, and then you have 1 over u du. So now you're going to have half ln u. The integral of 1 over u is going to be ln u. Notice that I didn't say absolute values, because this ones, they are positive. But if you get negative 1 here, that's where you're going to involve absolute values. But since the boundaries are positive, there's no need to include the absolute values or that. So you're just going to have half ln u from 1 to 4. Then you just plug that in. So you're going to have ln 4 minus ln 1. Then that's just going to be ln 1, we know that it's 0, and ln 4, we know that ln 4 will be expressed as ln 2 squared. Now, notice that you'll have 2 squared, right? And ln 1, we know that that's 0, so you're just going to basically have something like this. And now, notice that you can take the 2 outside, and the 2 by half is just going to be 1. And then you'll just have ln 2 as your final answer, because this 2 is going to come outside, and notice that you'll have 2 over 2, and then your final answer will be ln 2. But now, that's not the only way you can work out this integral. I mean, if you know algebra, if you do a quick algebra there, you have x squared plus 2x plus 1. And then you're integrating this from 0 to 1 dx. Now, notice that you can further simplify this. Notice that you're integrating from 0 to 1 into x plus 1. Now, what is this? X squared plus 2x plus 1. This is a perfect square number. So that's just going to be x plus 1 into x plus 1. Or, for short, you can just say it's x plus 1 squared. So now this x plus 1 and the x plus 1 will cancel, and this is the same as the integral from 0 to 1 of 1 over x plus 1. So there are multiple ways you can solve one integral, and if you know multiple methods of solving one integral, it will really help. Then now you can use substitution. Let u equals x plus 1. Let u equals x plus 1, then du is the same as dx. Then now this becomes, now you change the boundaries of 2. So now you have 1 over u, dx is the same as du. So now you have something like this. So now you can just work out this integral. It's just going to be ln u. No absolute values needed, because all these values, they are positive. So now you have ln u from 1 to 2. You have ln u from 1 to 2. So you'll have ln 2 minus ln 1. And then ln 1, that's just going to be 0. So the answer will just be ln 2. The answer will just be ln 2, which is the same as this one. So multiple ways, you can do this in multiple ways. It doesn't really matter. You can solve this integral in multiple ways. So that's just the substitution revision. You can change the boundaries of this, and where you do substitution is basically based on composition of functions. You substitute in the inside function. So if you look at this problem, making x squared plus 2x plus 1 helps, because its derivative will just cancel out, and the interval from that will basically be easy to like integrate. Now let's work out integration by parts. So I'm just gonna do one problem for substitution and do one problem for by parts, just to like give you a reminder of what's happening. Now let's say we try to evaluate the indefinite integral of this one. Now, if you're familiar with the method integration by parts, you know that the formula goes like the integral of u dv is equals to uv minus the integral of v du. So now, this is the given integral. So we must express this integral as u dv. So you must identify u from this integral. Now, u will be a term or a variable that will make it easier to integrate when you integrate dv. When you integrate dv, this is u. It doesn't look like u. Yeah, it's u. So now, u, when you derivate u du, when you derivate u, you get du. When you have that, it must give you like a simple integral when you work out on that. So what I'm saying is like you have to pick u, and the rest of that will be dv. Now dv must be integratable. Dv must be integratable. So notice that here both x and e to the power minus x can be integrated directly. But now letting u be x will make it simple to work out the integral from this side. If we let me just show you something. If we say dv equals x, that means x dx, then that means that v equals x squared over 2. And then u equals e to the power minus x, then that means that du equals negative e to the power minus x. Now, will you be able to find remember you have this part, the integral of v du, which is just x squared over 2 multiplied by e to the power minus x dx. Now, notice that when you make u to be e to the power minus x, you get a complicated integral on the other side. That means that your substitution is wrong. That means that you chose wrong variables to substitute in terms of u and dv. So it already shows you that this is wrong. You shouldn't do something like this. So u, it's a variable that will make you easily integrate when you find the integral of e to the power minus x. So what I'm saying is that u will be equals to x, and then that means that du will be the same as dx, or 1 dx, which is just dx. And now that means that dv will be equals to e to the power minus x dx. So that means that v will be equals to, you integrate e to the power minus x, you can do that directly, so it will be minus e to the power minus x. So now working on that, you have something like this. So that means that the integral of x multiplied by e to the power minus x dx will just be equals to uv, which is just x, and v is minus e to the power minus x. And then you subtract the integral of v, which is just minus e to the power minus x, and now du is dx. So that means you have something like this. So that's how you can like work out on this one. So now simplifying this one, you'll have minus xe to the power minus x minus, and now the integral of this one is just going to be positive e to the power minus x, and then you add a constant when you're done. So that will be the integral of xe to the power minus x dx. So it's always best to like check if your answer is accurate. Let's check if our answer is accurate. If we differentiate this, we should be able to get x multiplied by e to the power minus x. Let's differentiate this. So let's use product rule with minus x and e to the power minus x. So if we derivate minus x, we're going to get minus 1. We leave e to the power minus x, and now it's plus into minus x. Now you derivate e to the power minus x, then you're going to have minus e to the power minus x. And now you're going to have the derivative of this is just going to be positive e to the power minus x, because when you derivate this one, it's just going to be minus 1, and you have a negative here, which is just going to be positive. Now, that means you have minus e to the power minus x, and then you'll have negative into negative, which is just positive, and then you have positive x e to the power minus x plus e to the power minus x. When you differentiate this whole thing, the derivative of a constant is 0. Now this term cancels this term, and notice that we end up with what's there. So when you integrate, try to like derivate and see if you can be able to like get the same function that you were integrating. So that's it about this video. So try to like see if you can like integrate ln x. Well, let me just put square here. try to see if you can be able to integrate ln x all square without on that integral, and try to like analyze if it's by substitution or by parts, and also try to like see if you can like integrate this one and try to like work out whether it's through substitution, let me say cubed, try to like see if it's through substitution or by parts. Both problems, one of these problems is through substitution, the other one is just by parts. Try to like analyze if you can be able to like separate this, and if you cannot distinguish either this problem is through substitution or by parts, check out my video on how you identify whether the integral is through substitution or by parts, which I uploaded a few months back. Thanks for watching. Don't forget to share and subscribe.